Good morning, dear students. Again, our college is run by Navayog Shikshan Prasarak Mandal Chapoli, Sanjeevanee Mahavidyalaya Chapoli, affiliated to Swami Ramanand Marathwada University, Nanded. This lecture is for BSc first year physics students. Paper number 1, Mechanics and Properties of Matter. Third lecture from unit Viscosity. Department of Physics welcomes to you again back. Here we discuss viscosity. Already we have seen what is viscosity, what are the factors affecting viscosity, what are the causes of viscosity, what is the unit of viscosity, how it is measured, what about streamline, what about the laminar streamline, what about the turbulent flow. All these things we have discussed in previous lectures. Now we discuss on the various concepts of viscosity, such as velocity, critical velocity, their pictorial diagram, and so on. Here's viscosity. Already we have seen the concept. You know, thick viscous and thin viscous liquids or fluids, we say. Viscosity possesses by any fluid, may be liquid, may be gas. Already I have seen. Streamline flow. We have observed that water flowing from a tap. If suppose tap is opened, then it has a smooth texture. But when the remember, provided the flow rate is what? Low. But when the flow rate is increased, then what happens? There exists a disturbance in the flow after a certain velocity. Up to a certain velocity, what happens? Its texture of flow of water from the tap is smooth. We say laminar flow. It is said to be streamline flow. But as we raise its velocity, then what happens? A velocity increases, and one certain velocity reaches. At that velocity, the water from the tap, what happens? Get disturbed. I mean, disturbance there exists in the flow of water from the tap. So from which velocity it is going to disturb, that is said to be critical velocity. The velocity at which the streamline flow getting to turn into turbulent flow is called as what? Critical velocity. So are you getting it or not? Critical velocity is nothing but what? The velocity at which the fluid changes from streamline flow to turbulent flow. So this velocity is said to be what? Critical velocity. You see here a pipe. Water is flowing through this pipe, continuously flowing. Here different layers you are going to observe. This is what a streamline flow. And when the speed of the water or velocity of the water is increased by using or by moving a cork, then what happens? This is the velocity for a given fluid for a given tube. Critical velocity, remember, velocity for a given fluid for a given tube beyond which laminar flow gets converted into turbulent flow. When the velocity of the fluid exceeds the critical velocity, the character of flow, I mean, there is a change in texture. Character of flow changes, texture of the flow changes from laminar to turbulent. This point. This critical velocity applies only for given fluid in a given tube. Velocity applies only for given fluid in a given tube only. So I mean critical velocity of a particular yes, we have seen the critical velocity is nothing but the velocity at which the texture of flow of fluid changes from laminar to turbulent. Now I will show you a picture, exact nature of the turbulent and laminar flow of the fluid. See now, here fluid is going to flow from left to right like this. Here flow is what? Steady. Texture you see here, all these layers moves in a parallel way, but if we observe this figure, then what? As here velocity is increasing, and one stage will reach, at that stage, I mean at that particular velocity, this streamline flow, or we say laminar flow, is going to change. This laminar flow is going to change, or it turns into what we say turbulent flow. I mean, in case of this turbulent flow, these layers are not moving parallel to each other, but the layers of the liquid, they move, they flow by a zigzag nature. They intermix with each other. So that we can say this is a turbulent flow. And this flow, laminar to turbulent, exists from a certain velocity that is said to be critical velocity of the flow. So from this figure you will get the idea of laminar flow and turbulent flow. Critical velocity and Reynolds number. The maximum velocity up to which fluid motion is steady, called as critical. You can define critical velocity in this way also. It is a maximum velocity up to which the fluid motion or fluid moves. Fluid's texture is nothing but the laminar, or we say streamline. Such a maximum velocity is called as what? Critical velocity. And Reynolds through experiment established that in case of motion of a fluid in thin tubes, critical velocity depends upon the density and viscosity of the fluid as well as the radius of the tube. I mean, critical velocity depends upon what? Three factors. What are those? Viscosity of the fluid, radius of the tube, and density of the fluid. So critical velocity is more if the viscosity is more. Critical velocity is less if radius of the pipe is more. And here density is suppose more, then also what we say critical velocity. I mean critical velocity is directly proportional to what? Eta, that is viscosity, and inversely proportional to the radius of the tube, a product of radius of the tube and density of the liquid. So in this way, if proportionality sign is removed, then we will obtain a constant of proportionality, we say Reynolds number. And Reynolds number, critical velocity is nothing but it is equals to Reynolds number into eta upon product of R and density. So in this way, you remember this relation of the critical velocity in terms of Reynolds number. I will show you interesting thing now again, but remember sometimes such examples are not necessary to give you, but one should not go in a incorrect way in our day-to-day life also. That's why I'm going to show you this figure image. You see carefully, and it is written, first of all you remember smoking is injurious to health. You take this lesson throughout in your life. Here now I want to show you what? Here smoke is coming from this source. Up to this it is going to flow in a steady pattern, in a laminar pattern, or we say streamline. and here velocity is increasing. At this particular velocity, critical velocity, here velocity is increased, and this flow of the fluid is going to change and they make intermixed with each other. Such a flow is said to be what? Turbulent flow. Getting it? So remember this, what? This line you remember throughout your life. Now laminar flow, here you shall see. Simple diagram is drawn here showing laminar, or we say streamline flow. Laminar flow is defined as the type of flow in which the liquid particle moves along well-defined paths or streamlines, and all the streamlines are straight and fair. Then what are the factors responsible for the laminar flow? High viscosity of the fluid, low velocity of the fluid, and less flow area of the fluid. For example, flow through pipe of uniform cross section. Pipe is suppose uniform. Then also what happens? There will be a uniform flow, that is said to be laminar flow. And in case of turbulent, already I have told you, the layers intermixed with each other. They flow in, they move in zigzag way. Here figure is shown. For example, turbulent flow is defined as the type of flow in which the fluid particles move in a zigzag way. The fluid particles crosses the paths of each other, like this in this figure I have shown. For example, the flow in river at the time of flood, flow through the pipe of different cross sections. So river water, whenever floods are coming, flood is there, it is nothing but what? Turbulent flow. Laminar flow is also defined as the type of in which the fluid particles move along well-defined path or streamline, and streamlines are straight and parallel. This type of flow is known as laminar flow. It is also called as what? Streamline flow. And turbulent flow is nothing but type of flow in which fluid particles move zigzag way. Already I have told it. This is nothing but again velocity number, Reynolds number, we have already seen. These velocities, what happens? These are the different velocities of flow of fluid from lower level to higher level. As we go to higher level, velocity increases. This already we have seen. Now what is laminar flow? And flow when velocity is increased. Laminar flow changes when laminar to flow turbulent takes place when if the velocity of the fluid is increased, diameter of the pipe is increased, and viscosity of the fluid is decreased. Viscosity is decreased. I mean, thinner viscous liquid fluids are there, then we say that there is a possibility of laminar to turbulent flow. Reynolds was the first to demonstrate that the transition from laminar to turbulent depends not only on the mean velocity but on the quantity rho v d upon mu is called as what? Reynolds number. What about the significance of the Reynolds number? This is very important concept in our syllabus. A Reynolds number already nothing but, or its mathematical expression already I have told you in previous slide. Reynolds number R E is equals to rho V D upon mu, where rho is what? Density, velocity, D is what? Diameter. Reynolds number can be interpreted as the ratio of internal inertial to viscous effects. At low Reynolds number, what happens? Reynolds number is low, in the sense viscous effect is comparable to inertial effect. Flow behaves in orderly manner, laminar flow. See, Reynolds number is low in the sense the flow behaves in a what? Laminar flow. And whenever Reynolds number is high, means what? Density is more, velocity is more, and so on. Viscous effect is insignificant compared with the inertial effect. The flow pattern is irregular, unsteady. We say turbulent. So from this